All right, folks. I guess we'll get started, and I can add some more people as people join us. Thanks very much for joining us for this webinar this afternoon. Happy to have Dr. Aitazaz Farooque with us. Aitazaz is with the University of Prince Edward Island's School of Sustainable Design Engineering. And we've been doing some projects with the Potato Board and with AIM with Aitazaz for the last number of years, and some very interesting work that's been going on, particularly around the use of measuring soil electroconductivity for managing zones in your field and possibly managing our fields in a variable rate way, whether that be variable rate fertility or seed spacing, or possibly even we're doing some investigation on managing compaction in a variable way within fields. So Aitazaz is going to give us just a brief walkthrough of some of the work that he's been doing as with growers. All of this work has been happening directly with producers, so be able to fill you in some of that and some of last year's results. And then also going to talk, as I was going to talk a little bit about the compaction work that we just started in the last year or two as well. And again, that's happening more on a field scale. So he'll be able to talk about that. So with that, Aitazaz, I will let you take it away. And I think you're on mute.
Yeah, thank you very much, Ryan. Appreciate the support from the board and you. Before I kick things off, I would like to acknowledge at the start, because the last year was a COVID year for all of us, and because of the restriction with the university. So Evan McDonald was the key to the last year data collection and help, and Ryan and Morgan, they helped to start the things off, because if they weren't there, we won't be able to have a trial because of the restrictions in place, but slowly we were able to accomplish. So thank you everyone for being with us. And I'm gonna, as Ryan said, so I'm gonna be talking a little bit about the soil EC and its relation to topography and how we can manage our nutrients based on that, and bit of a preliminary investigation we had in terms of detecting the compaction and see if there is a feasibility for that. So before, I want to just build a story so that the growers require increase in yield, and that necessarily is not true that we manage our fields on the uniform basis, because we always deal with the spatial variability within the fields, and that variability could be caused by many different factors, and among some of those are topography, climate, weather conditions, inputs, plowing, interaction within the soil profile. So those all cause the spatial variation within the field. And that variability ultimately reflects the change in the yield. And at the end of the day, if we can manage, and we are capable to manage and apply our inputs based on that variability, we can improve profitability and protect the environment. So for this, as Ryan said, so for this particular project, so we are investigating the potential of the 2LEM2 sensor, which basically measure the electrical conductivity. But in the past year, we did not only use the 2LEM, but combined with the topography and use the SWAT tool. Basically, it works on the same principle, but it takes into account the topography. As you all know, in PEI, we don't deal with a flat field, so we have the topography into effect, and that kind of direct the nutrients in movement and whatnot. So that's why it would be interesting to see if we can combine EC with the topography in our conditions and kind of tailor our management based on that. So the objectives of this project were to look at the variability, which we established in the earlier years, that we deal with the variability, and that variability exists within potato fields in PEI. Secondly, identify the factors which are causing the change in the yield, and those are different factors, moisture, nutrients, and whatnot. And then sensors for accurate prediction. So in this particular objective, we are looking at the different sensors, NDVI, EC, topography, to see if we can correlate those sensors with the physical attributes to basically measure that variability, and develop and evaluate the management zones for the nutrient management and also the variable rate seeding. So remember, just want to emphasize that last year we not only did the nutrient management variably, but also did a variable rate seeding trial as well out in Surrey. And then based on that, we developed the zones. We apply potash primarily last year, and also look at the yield data to see whether that variable rate was doing the job or where we sit on them in terms of profitability. So these are some images during data collection. So obviously we had the soil samples within the zone, and we get them analyzed for soil, different parameters, and we get all the parameters were analyzed from PI Analytical. So we had sensor data, which was conductivity in horizontal direction and perpendicular direction, slope data, NDVI data, moisture data. And also we had the yield monitor data. And not only we relied on the yield monitor, although we calibrated the yield monitors, but also we had the digs in those zones to verify whether our recommendations were working in terms of the variable rate seeding. Fertility management and seeding. So just to kind of kick things off with the results. So we had 4 sites last year, one in Baddeck, one in Hamilton, one in Surrey, and one in O'Leary. So this is the layout for the O'Leary site, in Hamilton and Surrey. So I'm gonna present results for these 3 fields, and Surrey field was under variable rate seeding, and Hamilton and O'Leary, they were under the variable rate potash application. So before we started things off, so we had the soil sampling done, and also we did the SWAT mapping based on the variability. We developed the management zone. And in this particular study, last year, we decided to go with the Olympian strategy, that we are feeding our best athletes, like the low yielding potential areas, we are feeding more. And compared to the less productive zone, we will be applying less of the potash. So so that was done prior to seeding. So the maps were generated, and then these are the application rates. So we treated 2 check areas, which we can call the traditional grower practice. And then we treated the 2 other areas as a variable rate. And then we also did a math on that and find out how much area is that. So the check areas were about 6 acres, and the variable rate areas were about 10 acres. And according to applied maps, so we did find out that on an average, our rate for the potash was to 11 pound per acre and to 15 pound per acre for this study. So that application was performed based on the prescription map. And then here is the yield monitor data for the same field. You can see that there is quite a bit of variation within the field in terms of the yield. So it varied from 102 to 500 weight per acre. And also in the so this is the variation I like in the low yielding area. So that was from 102 to 309, and then 309 to 337 in the medium zones, and high productive range from 337 to 500 weight per acre. So in terms of the yield comparison, when we overlaid that with the fertility map or the prescription map, we did find that in the high yielding areas, those generated high yield, as highly productive areas, they yielded high, and compared to the low productive areas. And when we look at the yield differences based on the yield monitor data, so we did find that there was a 300 weight acre more in the variable rate section. And when we did a bit of a math on that and find out the economics, so that 300 weight per acre, so using that, so we were able to generate $36 more per acre by using the similar amount of fertilizer, because we did calculate the average fertilizer in those. So the return on the investment, so that was roughly $21 per acre, because in order to do a SWAT map using and combining EC and topography to come up with those management zone. So last year the rate was about $15, but in the coming year it will be about $8. So the return on investment was about $21 per potash application. And remember, those zones can be used for other applications such as the lime, nitrogen, irrigation, planting, seeding. So all those applications still can add on even additional return in terms of the validity and accuracy of those zones. So this is a more like a visual display. So on the left-hand side, so that's the SWAT map. And in the middle is the NDVI map, and on the right is the yield map. And you can see even with the NDVI in SWAT, there was a very good resemblance. And you can see, for example, in these areas right in the middle, if you can see my cursor. So, and also if you look here, so on the SWAT map, so that was sort of poor productivity. And if you look at the yield, so that was also poor. So there was a very good match in terms of the SWAT and the NDVI and the yield in terms in Hamilton field. So also as I said, so from those zones, so we had about 8 samples from each zone where we collected the soil, we collected the moisture, and we analyzed those soil samples for the nutrients, and we look at the variability within those zones. So these are some parameters we did the zonal analysis for, and you can see there are some differences. For example, in terms of phosphate, so there was not much of a difference, and that is also true because we applied basically in the variable rate and the uniform rate similar amounts, so there was non-significant difference in that. The moisture was slightly variable in low areas or eroded areas or low productive areas. We got the less of the moisture, and in highly productive areas or good soil health areas, we got the higher moisture content. So just want to briefly walk you through over the results from O'Leary. So similar strategy, we did the SWAT mapping, come up with the management zone, then had the check areas and variable rate areas, and then applied the potash variably. And we did a math on that. About 5 acres were check areas or uniform management, and then 15 acres were under variable rate. And then the average rate was about 223 pounds per acre. And for the variable rate, so that was basically the same as per the applied map. So in terms of the yield comparison, so the yield was highly variable in O'Leary too, and it provided us a very good match with the fertility. And in terms of, so we were able to generate about 300 weight per acre more in the variable rate sections when compared to the check areas. And we were able to generate about $35 more per acre in the variable rates section, applying the similar amount of fertilizer. And again, because the $15 was the rate to use to generate those prescription maps or management zone using the SWAT, so the return was roughly about $20 in O'Leary field, the return on investment. So again, just want to emphasize, this was only for the potash, and when we include other applications, lime, nitrogen, irrigation, planting, so this return could be slightly higher. And here is a visual display where you can see the SWAT map and the NDVI map and the yield map from the yield monitor. And you can see that in terms, for example, here in the corner for the SWAT map, so that was sort of a low yielding. And if you look at the NDVI, that provided a very good resemblance that it was low, the yield was lower, NDVI, the plants weren't healthy. So visually, we did also see that there was a very good match and a good correlation between SWAT map, NDVI, and the variation in the yield, which provided us the evidence that those variable rate zone performed really well. And again, some comparison for the various parameters which we were collecting over the growing season for those fields. So now next trial we had in terms of the EC project that was related to the variable rate seeding. And the idea was that once we have developed the management zone, we know that the productivity will vary if we can adjust the seed rating based on that. So this was the field in Surrey, and the 17 inches is the standard seed spacing. We varied it slightly, 18.7 and 15.3. And the idea was that we want to put potatoes slightly tighter in the productive areas and kind of space them out a little bit in terms of the low productive areas, and then kind of compare it with the traditional practice. So this was drone imagery, and we found quite a bit of difference in terms of the plant count, canopy cover in those different zones and grids. And this is more like emergence assessment. So in 18.7 inches plant spacing, so we found the total number of plants and the canopy cover, and then all those. So we did calculated that and kind of verified that how it's going to translate that into the yield. So, and also we physically verified that spacing within the field, and that was quite accurate in terms of the emergence. So this was the SWAT map based on the EC. So on the left-hand side around here, you can see all red areas. So those are low productive areas. Then yellow areas are sort of medium, and then these green areas are sort of a highly productive areas based on the EC and topography data. So on this one, so around here we had about 18.7, then 17, and then 15.3 spacing, and rest of all the field was treated as 17 inches spacing, which was a traditional practice. So we did not have the yield monitor data for this site yet because the cable was broken, and we ordered a new one, but we're gonna overlay that yield monitor right on that. But we had the manual digs, which we collected from 24 different points within the field from the zones and those spacing and those different spacing. And we did find that the tighter spacing in the productive areas generated about 450 hundredweight per acre. The traditional spacing was 350 roughly. And where we spread them out a little bit and provided a more opportunity for the nutrient uptake and moisture and whatnot. So the wider spaces that based on the digs generated about 425 hundredweight per acre. So based on this last year trial, we can say that the variable rate seeding worked for this trial. And I think we will be exploring more on the variable rate seeding based on the SWAT and EC mapping to see if the results are even better. Because in PEI, we have the soil health is an issue, the erosion is an issue. So having the same seed rate all over the place without looking at the productivity potential, I think we are providing more competition for the plants, and that's not helping, and the yield's gonna be lower. But if we can do that variably, so that there is a good chance that we can enhance the yield, and we can save some on the seeding side of things. So just to conclude this experiment, so the management zones were developed and the application of the potash was accomplished, and the general feeling based on the results is that it was profitable. So it balanced out and even generated about $20 more per acres. And then variable rate seed was cost effective. And then also we did found that the tighter spacing, so that resulted in the higher yield and also the variable rate seeding and spacing the potatoes out a little bit based on the lower productivity. That was also helpful, and it resulted in a higher yield compared to control. And then also this year we will be expanding on this and kind of replicating the same trial and evaluating the profitability again in few fields around PEI so that we can even establish. So And so this is one of the projects. So that was, we have, as Ryan said, we have been doing for the last at least few years. And we started with the variability. We characterize and quantify. We develop zones, look at the potential, compare the yield. And the last year, we actually implemented and applied those zones to see whether they are workable, they are profitable, they are feasible, and there is the appetite or the opportunity to even implement that at a larger scale. So I'm just gonna briefly go over the second part of it, which we started recently, and we had some preliminary experimentation on that, is to see if we can use the EC to look at and we can detect the compaction, and so that we can look at the potential if we can tailor our tillage depth to break the hard pan and make it more for in terms of the soil health. So we all know that the presence of the subsoil hard pan, so that is a yield limiting factor. And the idea is that since the EC that gives us a response from 3 meters below the soil surface, so if we can fraction that response and kind of see if we can detect that compaction. And then in this particular study, so it was quite a bit of labor because we were in the fields at least 4 fields, but we had about 9 to 12 samples in each field. And then we did the EC survey, and then we collected the soil. We determined the penetrometer reading to detect the compaction using the handheld, and then also had the soil moisture with the TDR probes, collected the soil, verified that soil moisture in the lab, and also determined the bulk density at the various steps. So these are a few images during the data collection, and we were, as I said, so we were fractioning the total depth and trying to see where. And also this was done in consultation with the growers, because growers were the guide to tell us where they seem like to have where they seem to have the compaction, so that we can compare that with the other areas. So here are some other pictures from the different fields, and you can see the EC and some analytical data which we did in the lab to calculate the bulk density and moisture at various steps. And just bringing you back to the EC, and as I said, so it can measure the conductivity 3 meters below the soil surface, and we developed an equation that we can fraction that for the, say, top 30 centimeters, 60 centimeters, 90. And the idea was that if we can fraction that response, then if we can detect that whether the compaction is more in the top layer or sort of a subsurface. And the conductivity works on the magnetic field basically, and it has transmitters and receivers, and we can get the response. I don't want to get into the science of it. So this is just to kind of have so for the 20 centimeter depth, then 40, then 60 centimeter depth, you can look at the moisture, how that changes within those different depths. And then also on the bulk density side of things, which we calculated in the lab, that it was variable. So the bulk density was increasing as we go deeper in general. So which kind of gives that that there was a bit of a compaction. And then also we compared we also look at the resistance to compaction that was with the handheld compaction meter. So we calculated the resistance, and then so that was done at the 4 different depths in terms of inches, and it was easy to operate that resistance meter like at a lower depth. As we go deeper, so it gets hard and hard. So that was a basic trend here. So then the idea was that, yes, now we have the data, and the idea here was to look at the feasibility, whether we can detect the compaction with the EC. So we plotted the regression, and then on the horizontal axis, we had the conductivity from the EC, and then on the vertical axis, we had the resistance. We had all kind of curves, and I developed with the bulk density and temperature and this and that. So I just want to show that it for the different depths. So the relationship between the ground conductivity and the resistance was from somewhere from 0.6 to 0.68. So that's what we found, and we fractioned the response at different depths. So this slide show that there was a good correlation, not perfect, but there was a good correlation between conductivity and the compaction. So then we did the survey in the field. So where we collected the EC data by dragging the equipment. And then once we do that, and then that was the raw data. We bring it back to the lab. We fraction that for the top 30 centimeter. On the left-hand side is the EC map, and on the right-hand side is the compaction map, or the compaction depth. So you can see the majority of the field in the top 30 centimeter that wasn't compacted, except some areas at the start and on the left-hand side of that. And then when we go slightly lower, so say this is the map for the 90 centimeters, so we can see a sign of a bit compaction and the EC. So there was a good match. Now, again, not perfect, but it does indicate that the conductivity correlated or matched really well with the depth. And here is the 60 centimeter, and here is another map for the 120 centimeter. So again, based on all that mapping, and we did few surveys within the field around when it was wet, when it was dry, just to kind of see how the variation looked like. So, but the idea was to identify, to see if there is a potential to detect that compaction. So this was the second field last year we had. So again, we did a couple of surveys in that field around different dates to see, and those were not under potatoes. So both of these fields were under rotation, so that we can have a better sense. On the left-hand side is the EC map, which we developed based on the point data. And then we use that compaction equation to convert that into top 30 centimeters, 60, 90, and 120 centimeter. And you can see there is a bit of a comparison, not perfect, but on the areas where it is red, it seemed to have a red conductivity, except in the middle, that showed that there was lower, or the HCB was lower, but that didn't detect the compaction. And here is the 60 centimeter. So again, similar trend. So good, reasonable match, not perfect. So here is the 90 centimeter compaction map below the soil surface, and 120. So we fraction that response and look at the depth. So in general, what we find that in the upper 30 centimeter, the compaction seemed to be lower in those selected field, and as we go deeper, so the conductivity was detecting some level of compaction. But as I said, so this was a more like a pilot study, a preliminary study. We did not have like a very, very extensive or detailed data collection, but this was just to look at the potential. And we did see that there is a potential to go around and go on that direction and look and do some more study to establish that if we can detect detection. And just on the same topic, when we did the EC mapping using the SWAT, so we have two sets of data, EC shallow and EC deep. So I did not have any validation data set for that, but I did find that this data, when we are developing the management zones, that could also be useful, that if we can use the same data set and see if we can detect the compaction. But this is just a visual display, how the EC deep and how the EC shallow kind of vary. So you can see that it is slightly different, and the trend is different between two layers. And again, that data can be used along with the same same SWOT mapping because it comes from it. And if there is a potential and the equation develop, and we can maybe use the same data set to see where we are looking at the compaction as well. So in conclusion of this trial, we did find that the higher values of temperature, moisture, and bulk density at the deeper depths. So the fieldwork data collection reflected that there was a presence of hard pan, and about 60 to 70% of the time, EC was well correlated with the hard pan. And we also did the layered response using the equation so that we are not representing the full story, but more like a depth-wise story, which was showing a bit of match. And in conclusion, I think we need to expand a little bit more on that, and maybe a graduate student study more detailed way so that we can have a bit more confidence before we recommend that that the EC can be correlated with the compaction. So at the end, I would like to thank Prince Edward Island Potato Board and NSERC and MyTax and my team at UPEI for their help during the data collection. And I'm also very thankful to Evan McDonald for all his support during the COVID year, during data collection, and he was available when we were on the lockdown. And Ryan and Morgan for your support during the sampling, and Dalhousie and UPI administration. Thank you very much to you all, and I can take any questions you might have.
Yeah, great. Thanks, Aitazaz. So we did, just to give you a little bit too, and in addition to this, so the fields in the compaction study, and you can correct if I say anything wrong here, Aitazaz, we're also going to take some yield samples in those fields this coming year.
Yeah.
And in those fields, we also did some ripping versus not ripping in those fields. So we have some parts of the fields that were subsoiled and parts of the fields that weren't.
No, I had that in mind, Ryan, and I kind of draw those lines because I know, for example, I can go to this slide, this field. So which was, I can't remember the name of the site, but I know in the middle, so it was subsoil, and on this side, like right in the middle, there were two flags, and we can map those and kind of plot right on top, like it wasn't subsoil, but on the sides it was subsoil. So based on the compaction trend we got. So for example, in this field, so right in the middle, it wasn't subsoil, but on the sides it was. So which kind of matches up a little bit with the understanding.
So we're going to follow up in that this year, and we'll follow up in the potato year and see if sort of the compaction map and the EC map sort of tracks with the yield in those parts of the field as well.
Absolutely.
So that'll be interesting. One comment that was in the chat was, do you think that the bedrock below 90 centimeters, because when we get below 90 centimeters, we're really not talking about soil so much, does that influence the EC when it comes to compaction, or does that, do you think that has much of an actual effect on yield?
I think that's a little too deep from the root zone, so maybe not, but I'm not 100% sure. Again, when we correlate that or overlay the yield map on top, so that will give us a bit of understanding what happened, because as I said, we can have a conductivity 3 meters below the soil surface, and we can fraction that with whatever depth we want. So I think it will be interesting to see and overlay the yield map to see whether the compaction at 60 centimeter was influential or 90. So I think that'll be a good comparison, Brian.
Right. So normally when I've been doing work with growers about compaction, and we've been measuring it in fields and kind of measuring the depth of hard pan, oftentimes the hard pan is somewhere around 12 inches or 30 centimeters. And sometimes it's higher and sometimes it's lower. Do you think, with maybe some further study and some further investigation, could we tighten those those gradations up a little bit? Because right now you have 30 to 60, 60 to 90. Would it be possible to do more like, say, 0 to 15 and 15 to 30 and 30 to 45?
Yeah, that is doable. That is doable, because in our code we have, because we develop an equation and that runs by the bit of a program. Like it takes into account how high was the EC sensor from the ground, and then how deep we want to fraction that, what was the sensor type and which transmitter was emitting at that time. So that take into account, that's doable. We can tighter that at whatever depth we want.
Yeah, because I'm thinking for like the next time we do this, if we have it at 2 or 3 of the shallower settings or like measurements, that may enable us to kind of identify, is there a hard pan, and then how deep is it? And that's where I think going forward, that may be where this research becomes usable on a farm scale, where people can say, okay, I can get my field mapped, and then I can say, okay, maybe I need to do subsoiling in this part of the field, but this part of the field looks all right, and I don't have to, that sort of thing.
Yeah, no, absolutely. And I think at the end of the day, we want to tie this all up into the practicality side of things, like how deep we can go in terms of subsoiling. So that's also one of the consideration. And you're right. Like most of the time we are hitting the hard pan, like around 30 to 60 sort of range. And it was really, really hard to go and dig deeper anyway. So,
well, I mean, with a commercial subsoiling, like going much deeper than 17 or 18 inches is going to be really difficult. So
yeah, absolutely.
So trying to gradate it, or get the gradation in that top level, I think is the most important.
And I think going forward, Ryan, I'm thinking maybe up to say 50 to 60 centimeter below at max, because that's where the practicality comes into play. So if we can fraction that up to that depth with the tighter intervals and kind of see where we hit the compaction, that's going to lead us like where it would be best to go with the subsoiling and what depth.
Does anybody else have any questions on either the first stuff that Aitazaz shared on the management zones and the variable rate fertility, variable rate seeding, as well as the compaction that we just talked about? You can either put questions in or comments in the chat, or you can unmute yourself and ask a question as well, whatever is easiest. I will note too, so this was the first year for the management zone part of the project that the first 3 years of this project was working with Aitazaz's team to just map fields and try and relate yield to the EC. And they were able to find, like in those first 3 years, there was a really strong correlation between EC and yield. And it was one of the strongest predictors of yield was soil EC. So then this year was the first year that then we actually made a management change in these fields. And so as I showed on 3 fields, we changed potash, and 1 field we changed spacing. This coming year, I think it's going to be more like 2 and 2. We're going to change fertility on 2 and seed spacing on 2. But the seed spacing one looks really interesting to me in terms of if you were able to boost the yield in the normally poor performing area just by widening the spacing out a little bit, if that could be replicated on more fields, that would be, that'd be huge. So be interesting to see that over more fields if we can. Any other questions or comments, folks? Okay, so not hearing any. I do thank you for joining in and participating. If you have any questions after the fact that you want to send to me or to Aitazaz's email is there on the screen, so you can send it to him. You can talk to me. We're going to be, as I said, we're going to be setting up some more fields on that project again this year. And we're really glad to be working with Aitazaz and now a bit more with Evan as well, Evan McDonald on some of these projects. So we're really glad to have the participation. And I really want to thank the growers that have participated in this project since the get-go. So Jonathan McLennan, Nathan Ching, Black Pond Farms, Oyster Cove Farms, and Willard Waugh & Sons. They've been involved in this project for 4 years and really want to appreciate their help. And on the compaction project, we started that last year with Dunk River Farms, and that's going to be continuing this year too. So really appreciate the growers who help us with these projects and help us do this investigation. So okay, thanks a lot, Aitazaz.